Okay, homework 5 is solving linear inequalities. An inequality would be a less than or greater than, a less than or equal to, or greater than or equal to. You're going to be asked to write it in different notations. One will be an inequality, another one is set builder, interval, which that's the one we're going to use most, and a graphical, which is a number line. And the number line is going to help you with interval notation. So first we're going to talk about set builder notation. One example is the set A is equal to, the way you read this is the set of all x, this line there stands for the words such that. Okay, so we got all these values x such that x is an integer, meaning a whole number, positive or negative, and x is less than 3. That is how you would write the the set builder notation. Note that the symbol, that line, means such that. A is the set of all x such that x is x is an integer and is less than 3. Or in the equivalent set notation, that would mean you would list all of these, okay, that fit in both categories. Okay, it has to be an integer, meaning a whole number, positive and negative, and 0, and x has to be less than 3. So you'll notice this is the same thing as this, because these are listing all the numbers, all the integers that are less than 3. These ellipses, the dot dot dot, means it goes on, so it could start down here at -10, but we're not. We started at -1, 0, 1, and 2. Notice we did not put 3 in there because it's less than 3. Okay, so rewrite the set in by listing its elements. Make sure to use the appropriate set notation. If you need to use the dot 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 or ellipses, to indicate a pattern, make sure to list at least 4 elements in the set. All right, so this is going to say the set in equals the set of all x, and a lot of times I'll just say x such that x is an integer, meaning whole numbers, and x is, the set says 2 is less than x, which is less than or equal to 6. All right, so we have in. We got to label the set. Now we're not going to use a dot 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 because x is between 2 and 6, but it's not equal to 2. 2 is less than. If I cover this up, I can also read this as x is greater than 2. Well, those numbers would be 3, 4, 5, and because of that equal sign right there, we're going to also list 6. Those are all the values, all the integers between 2 and 6, but it includes 6 because of that equal sign. This one right here. X such that, or the set of all x, such that x is an integer and x is greater than 4. Okay, so on this, it's not equal to 4. So we got n is equal to, put these braces, the squiggly brackets, but they're called braces. We can't include 4. It's just the values greater than 4. So it's 5, 6, 7, 8, dot, 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 because it keeps on going. And the reason I listed 4 is because my directions told me to. These are called elements. All right. Interval notation. Okay, this is one that we are going to do the most. They're kind of like endpoints. Sometimes you're going to use parentheses, sometimes you're going to use brackets. Now, I teach this. It says write the following inequalities in interval notation and graph it on a number line. This is exactly what it's going to look like in Alex, or the way that it's read in Alex, but I say let's do the number line first. So if I did a number line, okay, and I'm really lazy on my number lines. We're talking about the number 2. So you have 2 here, it's right in the middle. We'll do 3 and 4. Pretty soon I'll just probably have 2. And over here to the left we have 1 and we have 0. And now you can make your number line bigger, but I don't really want to. Okay, first of all, if you see a greater than or a less than symbol, we're going to do what I call is open circle. Okay, it's just going to look like this. It's not filled in. I call it an open circle. And actually so do your instructions here. But if it's a greater than or equal to or a less than or equal to, you're going to have what I call a closed circle. And all that means is it's a circle that's filled in. Okay. Now, the other thing, so right now let's just go ahead and do that. We're going to use that when we graph. It's an open circle at 2. And it's all values greater than. This is a greater than symbol. So it's all these values to the right. Now down here, this approaches negative infinity because it goes on forever, and to the right it goes on to a positive infinity. So now that's the graph. We graphed it on a number line. Now you're going to do the interval notation, and we are going to, this is what we're going to use most in during the semester. If it is an open circle, it's rather going to be a parenthesis like that or like that. We might use both of them. We may use one parenthesis, and that's it. Closed circle, we use brackets. Okay, and depending on, we may use 1, we may use 2, we might use one of each. It all depends. Now the thing here is anytime you use infinity or negative infinity, it's always parenthesis. So right here, 2 is our endpoint. That's the smallest number because it's 2, 3, 4, 5, and so on. It's an open circle, so we start with a parenthesis. You're going to do comma, and then it's going to go to infinity. It never stops. And because infinity and negative infinity, it's always parentheses. Always, no matter what. Okay, so if you want to, you can do this. Infinity and negative infinity or vice versa. Those are always parentheses. Okay, so now this one right here, let's put it on a number line. Here's 3. Again, 2, 1. This side goes to negative infinity. 4, 5, 6, 7, 8, 9, 10. It goes on forever to a positive infinity. Because it's an equal sign, that means I'm going to have a closed circle at 3. And this says x is smaller than that. It's less than. So it goes this direction because these are all the values that are less than 3. So you want to, in interval notation, you always start with the smallest number first. Read it left to right. Well, this is going towards negative infinity. So we're going to start with negative infinity, and it's a parenthesis at negative infinity because infinities are always parentheses, whether it's positive or negative, and it stops at 3. And because it's a closed circle, we're going to use a bracket. Okay? 3 is larger than negative infinity, so that's why negative infinity goes first. Okay, so this one right here, we actually have 2 things we're going to graph. And it's not that you're going to deal a whole lot with ands or ors. You'll have some homework on it. I won't put it on the test. All right, so let's just graph this as two different ones. All right, so we got -2 and we got 1. On a number line, you want to put them in order. So we've got, let's say, -3, -2, -1, oops, 0. I'm not going to do it there, sorry. 1, and let's make it go to at least 2 anyway. There we go. All right, so let's graph this one first, okay? So this one here, it's going to be an closed circle at -2, and this has all values less than that. So it goes like that. Remember, negative infinity is here and positive infinity is here. Okay. Then we're going to have an open circle at 1, and it's all values x is greater than that, so it's all these values this way. Okay. Now, to do the interval notation, let's just, because it's or, we combine the two. So what's going to happen is, to do this one, and sooner or later, if you get really good at it, you will not need to do a number line. But for now, until you get this, I always suggest a number line. Okay. So I'm going to start with negative infinity because it is smaller than -2. So I'm going to go negative infinity. Start with parentheses with that. I'm going to go to -2. And because it's a closed circle, it will be a bracket. Then right here, beginning parenthesis 1, comma, to positive infinity. And again, because it's infinity, it's a parenthesis. Now what you're going to do is you're just going to put the union symbol in there. Okay? You're going to do the union. That's all there is to it. Just treat it different and put a U between it. This one right here. We're going to go from 2 to 5. And this I'm going to be really lazy. I'm going to put 2 here, and I'm going to put 5 here. If you want to list all your numbers between that, you can. We got negative infinity here, and we have infinity here. But x is between 2 and 5, so we don't even need these, but I'm going to still put them there. Okay, so at 2, we're going to have an open circle. At 5, we're going to have a closed circle. And x is between these two. So it's all these in here. Okay, so it's all these values. 3, well, I should have probably gone ahead and done 3 and 4. Okay, but that way you can see. All right, you don't need it. So right here, and notice when you do something like this, see how your symbols go the same direction? They're never, one's not going, they're not opposite. They're always going to be the same direction, or you've done something wrong. Because if I cover up this side, like all these numbers here, let's say 3, okay? 2 is less than 3. That should be correct, okay? Same thing with 3 here. It'd be 3 is less than or equal to 5. Well, if I cover up this, 2 is less than or equal to 5. If it was turned around, it wouldn't make it a true statement. If I covered up that part, okay, 2 is less than 5. So it's always a true statement no matter what I cover up. Interval notation. Start from the left. Smallest number goes first. It's a parenthesis at 2. It goes to 5. This has 2 endpoints. Because that's a filled in circle, it's going to be a bracket. And that's your interval notation. All right, now when you have an and, this is kind of like I say the overlap. Okay, and again, don't worry about ands and ors for your test. Just you will see it though in Alex. All right, so on our number line, we have 7, It's going to be down here, and we have 3 here. Okay. I might as well put 4, 5, 6, and I'll go ahead and do 8 and 9, and I'll do 2 and 1, even though I don't think I need those. And it goes infinity and negative infinity. Okay, so when you have an and, it has to fit in both categories. Okay, so in this one, let's go ahead and graph it. X is less than or equal to 7. Close circle. All values less than that go this direction. Okay. And x is greater than 3. So it's an open circle right here, and it's all these values right here. Okay. Now, when you have an and, it needs to fit in both of these, not just one. An or, it can fit here or here. That's why this is okay. Like if I picked a, let's say a -3 right here. -3 is less than or equal to -2, or -3 is greater. That's not true. It only has to fit in one of these. It doesn't have to fit in both. For and, it has to fit in both. So that's why it's the overlap right here. Now be careful. Because 3 counts here, but it doesn't here, it's going to be an open circle at, it's going to be a parenthesis at 3. Because even though it fits here, 3 is less than 7, 3 is not greater than 3. So that's why it's a parenthesis, because it doesn't include it, but that's like this, the stopping point, like 3.1 would fit in both of them, right? It doesn't say anything about integers, so it could be a 3.1. That would fit here and here. But 3 only fits in one of them, so parenthesis, but it goes to 7. 7 is in both of them. It's here, closed circle, and it's closed there. So that's going to be a bracket. And again, 7 is less than or equal to 7, and 7 is greater than 3. All right. Now, we're going to go to solving linear inequalities, okay, in one variable. So now, be careful. Don't change this to an equal sign. I see that a lot, or, it's a common mistake. All right, we're going to distribute. We get 3x. 3 times 4 is 12. Is greater than 5x minus 8. Just like we did with an equal sign, we're going to get our variables to one side. So I'm going to get rid of this 5x by subtracting 5x. That gives me 0 because I'm taking this over here. Okay. This gives me -2x plus 12 is greater than, because you just bring this symbol down, -8. Now, we treat this just like we would an equal sign until one condition, okay? So now I got to get my constant over here to the right because our variables are on the left. So I'm going to subtract the 12 because that's going to get rid of that plus 12. So I'm going to subtract 12 there. And I get -2x is greater than -20. Okay. So now, be very careful. I'm going to divide by -2. When you are working inequalities and you divide or multiply, because the same rule does for, goes with multiplication. But when you divide by a negative number, what happens is this symbol switches directions. So it's a greater than, it becomes a less than. And the reason it does that is because we are dividing by a negative number. If it's a positive, you leave it. But we're dividing by a negative number, so our symbol switches. This side gives us x. This gives us a positive 10. Okay. Now, that's an inequality. If it asks me to do set builder notation, what you would do is you'd put your braces, okay? And you just put this, the set of all x such that. You just put this x such that. And then put this. Okay? This is set builder notation. All right, now, does that have, that's got a dash in it, right? Yeah. In order to do interval notation, that's the way I'm going to like it, okay? Let's put it on a number line. Here's 10. Here's infinity. Here's negative infinity. If you want to do all your other numbers, you can do that. Open circle. And it's all values less than. So it goes that direction. Now, so this is a graph. Okay, put it on a number line. Interval notation is going to look like this. Parentheses, negative infinity to a positive 10, parentheses, because this is open circle. That's the one that we are going to use most. Interval notation. Guys, something you have to really be careful about. Make sure if you have a negative infinity in this problem or in your answer, it always goes first. It never goes at the end. Never. Positive infinity will, but never a negative. All right, so in this problem here, let's go ahead and distribute. Eight times x is 8x. 8 times negative 2 is negative 16. Bring down the minus 3x. Bring down the plus 5. Before I do anything else, I'm going to combine my like terms. Eight x and negative 3x gives us 5x. Negative 16 and 5 gives us negative 11. Bring this down. Okay. Now, on this problem, if it were me, I'd work it one way, okay? But when I teach, I still will I'm going to show you two different ways, okay? I'm going to take that 5x over there by subtracting it, because this is how I've taught you. You don't have to do it this way. In fact, if I was working it myself, I wouldn't. But I'll show you why. So I have negative 5x plus 16 is less than or equal to negative 11. I'm going to take the 16, get 16 over here, so I'm going to subtract 16 from both sides. I get negative 5x is less than or equal to negative 27. I'm going to divide by a negative 5. So what happens when we divide by a negative 5? A negative number, our symbol switches. So it becomes a greater than or equal to. This gives me a positive 1x, or just x. This here is going to give me a positive 27/5. Okay? Now, you can use a decimal, it's fine. Let me go back up to here, because some of you, and it's perfectly fine, you would have said, and this is how I would have worked it, add 11 to both sides, and I get 27 is less than or equal to 5x, divide by a positive 5. Because we're dividing by a positive 5, our symbol stays the same. So I have 27/5 is less than or equal to x. These two things are the exact same. They look totally different though. I read this as x is greater than or equal to 27/5. This is read as 27/5 is less than or equal to x. This is not a correct notation. I would not count it wrong, okay? But Usually what you're going to do is you're going to switch this around and you're going to say x is greater than, okay, because if I'm going to switch these, this is going to switch, and you could, if I read it from this side, you'd say x is greater than or equal to 27/5. Okay, so if I was going to put this in set builder notation, it'd be x, all set of all x, such that x is greater than or equal to 27/5. Okay, so now we got to put it on number line. Okay, well, 27/5 is kind of hard to graph, all right? So you want to make it a decimal in this particular case. Just so, because graphing is easier. And you could have put 5.4. That's perfectly fine. Okay? You can use either. But to graph it, here is 5 and here is 6. Because it's on the number line. If you want to put all your other numbers, that's perfectly fine. Okay, we have negative infinity here. We have positive infinity here. 5.4 is going to be about right here. Okay? And it says all values greater than that. So it goes this direction. So when I go to do interval notation, it's going to start here. I'm just going to use 27/5 because that's what I had. If you want to use 5.4, that's perfectly fine. It's equal, it's a closed circle, so it's bracket, and it goes to infinity, parentheses. Okay, number 7. We're going to distribute our 3. 3 times x is 3x. 3 times negative 3 is negative 9. Plus 17 is greater than or equal to 2x plus 8 plus x. Notice I do not use the 2 distributed here because it's not in parentheses. Before I start moving, I'm going to combine like terms. Okay, so I have 3x plus 8 is less than or equal to, over here I have 2x and x, which is 3x plus 8. Okay, you'll notice they look the same, but I'm going to finish it because, again, when your x's disappear, which it's going to happen, you're either going to have a true statement or you're going to have a false statement. That gives a 0, so does that. So we have 8 is less than or equal to 8. That is a true statement. So our answer here would be all real solutions or all real numbers, however you want to say it. Okay? Now, that means it's every number on the number line. And you really can't do, we won't ask you to do set builder notation, but we will ask you to do interval notation. Interval notation is written negative infinity to infinity. That takes care of all real numbers. It's every number on the number line. Okay, and this one right here. We learned to get rid of our fractions by multiplying by our least common denominator. In this case, 4 and 2, it's going to be 4. Now, you're going to multiply everything you see by 4. So that means this side, you're going to multiply this side by 4. You're going to multiply this by 4. And you're going to multiply this by 4. Now again, you can do this work down here if you want, but just because I'm running out of room, I'm going to get 4 times x is 4x, and I'll be explaining this in class anyway, and I'll do it then. But 4 times x is 4x. Now, when I bring that down, when we are doing this part right here, this is really over 1. So this 4 and that 4 are going to cancel each other out because one's in the top, one's in the bottom. And I'm left with 2x plus 1. Now, this right here, you can multiply, this is really over 1. You can multiply and go 4 times x is 4x divided by 2, and you're going to get 2x. Okay, again, 4x over 2, which is going to reduce to 2x. But what I do is I say 2 goes into 4 2 times, and 2 times x is 2x. Doesn't matter, however you do it, you do it. So I get 4x on this side. 2x and 2x is 4x plus 1. I'm going to get this 4x over to the other side by subtracting it. That gives us 0. I'm going to subtract it here, and that gives us 0. So we have 0 on this side. 0 plus 1 gives us 1. Well, this is a false statement. 0 is not greater than 1. So in that case, you have no solution. That means there's nothing out there that's going to work. Okay? So those are the different ways, and that's interval notation. We will use that all semester long. And I believe, yeah, that's all.